So let me explain what it is we're going to do today. This is a relatively short lesson. It just lays the foundation for the rest of Chapter 7. You're going to have some practice problems dealing with what's called absolute value today, and then you're going to get assignment number 4. Before I forget, with assignment number 3, I don't know if you recall, but some of you had handed in that assignment early, and you got it back. Everybody else handed it in on the due date, and you got it back. But the ones who handed it in on the due date, I didn't enter the marks into PowerSchool. So at some point later today, I'm just going to be walking around the room asking to see that assignment if you have it. And if you don't have it, I mean, I trust you. It's just an assignment. I need to know what the mark is so I can put it into PowerSchool. Okay. All right, absolute value. We're going to do this lesson. You're going to have some problems to practice dealing with what's called absolute value, and you're going to get assignment number 4, which is due Monday. You'll have lots of time today to get started on assignment 4. Assignment 4 kind of melts together some ideas from Unit 4, which is quadratic equations, and Chapter 5 of this unit, which is radicals. Okay, here we go. Absolute value. Determine the absolute value of numbers and expressions and relate absolute value to distance on a number line. We have a definition here. The absolute value of a number is defined as how far that number is from 0 on a number line. And who here has taken Physics 20 already or is taking Physics 20 now? Okay. Absolute value is the equivalent of saying no direction. It's like a scalar for you physics people. So it's like distance. When I say how far away am I from Millet, and I'm standing here, or I'm a little bit north of Leduc, it's 13 kilometers is how far I am. I don't say negative 13 kilometers or positive 13 kilometers. Those of you that are not in physics may be at a bit of a loss as to what we're talking about. Well, what I'm saying is this is like distance. I don't care about direction. It's a scalar. So absolute value of a number is the distance from that number to 0 on a number line. If the number is given by x, we use that symbol to mean absolute value of x. So when you see two vertical lines on both sides of a quantity, that means the absolute value of that quantity. So this means the absolute value of x. This is the absolute value of 12. This is the absolute value of negative pi. I'm not going to write that out. I'm just getting across the idea that absolute value, is indicated by using those two vertical lines. That's all. So determine the value of each and illustrate with a number line. And what's going to happen here, and it happened with me when I was first taught absolute value, is many of you, perhaps all of you, are going to at some point go, why? Why are we even doing this? What's the big deal? It's an important idea for later studies in math, particularly calculus. And let's not lose sight of the fact that this course is pre-calculus. That's what your textbook is called. Look at it, pre-calculus. It's preparing you for post-secondary and Math 31. Okay, so here's 0 on a number line. Here is negative 12 on a number line. What is the absolute value of negative 12? It's how far it is between those 2 points. This is the absolute value of negative 12. So how far is it? 12. It's that simple. The absolute value of negative 12 is 12. And this reinforces what I was just talking about distance. It has nothing to do with which direction you are relative to 0. It doesn't matter whether you're to the left of 0 or to the right of 0. Negative 12 is 12 units away from 0. So the absolute value of negative 12 is 12. It seems kind of silly, I know. What is the absolute value of 5? Well, how far away is 5 on a number line from 0? Well, if this is 0 and this is 5, this is the absolute value of 5. How far is it between those 2 points? 5. And I can see the looks on some of your faces is like, is that it? Kind of. The absolute value of a negative number is what you get if you forget about the negative. The absolute value of a positive number is that number. But I'm going to make it a little more challenging for us a little bit later today. So, example number 2. Two numbers, negative 10 and positive 6, are shown on a number line. What is the distance between the two numbers? So, what is the distance between this number and this number? That's what the question asks. Well, we can look at it and we can see it's 16. It's not a difficult question. It's almost like we're in grade 4 again or something. So the answer is 16. Write the distance between the two numbers using absolute values. Could I write that that distance is the absolute value of negative 10 plus the absolute value of 6? Is that a correct way to write the distance between those 2 points? Well, sure, because this is the absolute value of negative 10, and this is the absolute value of 6, and the distance between them would be the sum of the distances. That's okay. How many of you have ever, maybe in junior high, maybe in high school, done something on your calculator that involves subtraction? And you get a negative number, but you know it should be positive, and you just go, I'm just going to brush off the negative. I used to do that all the time. So what this means is if you want to find the difference between those two things, you can subtract them to get a distance, and then just take the absolute value, and that will give you how far apart they are. And you can try this. Negative 10 minus 6 is negative 16. Right? So this is equal to 10 plus 6. This is equal to the absolute value of negative 16. The absolute value of negative 16 is 16. What if you decided to subtract these numbers in the opposite order? Would you still get the right distance? Yes, because the absolute value ensures that if you do subtract the wrong way, you get the right answer. This would be the absolute value of 16. And all of these are equal to the same thing. So I want to summarize something here that, and you don't have to write this down, but I'm trying to prepare you for tomorrow and next week. Can somebody tell me when this is true? When am I allowed to just say, you know what, I'm not even going to use the absolute value symbols because I don't need them? Am I allowed to do that with any number?
If the number is greater than 0.
Right. And I'm going to go even further and say if x is greater than or equal to 0, because the absolute value of 0 is 0. So if I tell you what is the absolute value of 3, it's just 3. You don't need the absolute value signs. If I tell you what is the absolute value of 0, it's just 0. You don't need them. Now, this is where it gets tricky. If x is negative, then what would the absolute value of x be? This is very tricky. Sasha. It would be negative x. And some of you might say, that's excellent. Some of you might say, yeah, but the absolute value is supposed to be positive. Negative x will be positive if x is negative. If, for example, I have the absolute value of negative 4, then the thing that's in the absolute value sign is negative 4. But I know the absolute value of negative 4 is positive 4. So what would I have to do to negative 4 to make it positive 4? I'd have to multiply it by negative 1. This means take negative 1, multiply by whatever number is in there, and you're going to make it positive because it was negative. Okay. So we'll come back to that numerous times. In the meantime, let's get back to some questions here. Evaluate each expression. The absolute value of negative 4 minus 10. I think it serves you well to just think momentarily of the absolute value signs as just meaning a set of brackets. Figure out what it is inside. So we take negative 4 minus 10 and we get negative 14. And then we say, and I'm going to keep referring back to this even though the second line here is quite confusing. Then we say, since we're taking the absolute value of a negative number, we have to take that negative number and multiply it by negative 1 to make it positive 14. Over here with B, we have the absolute value of 3 minus 35. So I'm doing my order of operations, which says I multiply before I subtract. 5 times 7 is negative 35. 3 minus 35 is negative 32, which gives us positive 32. Is that right? 3 minus 35 is negative 32? Yeah. 5 times the absolute value of negative 2 plus the absolute value of negative 3. So I want to write this out a little bit different. I'm just writing it this way. It's not the brackets that I care about. But if you just look without thinking or looking at the big picture and you see this line and this line, you might think that's an absolute value pair. And it's not, right? There's an absolute value pair that's around the negative 3 and one that's around the negative 2. So this is 5 times 2 because the absolute value of negative 2 is 2 plus 3 because the absolute value of negative 3 is 3. So then it's 10 plus 3, which is 13. Negative 3 times the absolute value of negative 4/5 plus negative 5. Well, look. The next unit is kind of the pinnacle of algebra and difficulty in this course, and it involves fractions, and we have to start warming up to working with fractions. So, how do we handle negative 4 over 5 plus negative 5? The first thing we do is we line up the fractions so their numerators over denominators are quite clearly comparable. I want to take a detour away from this, and I think when I take these detours, I know that sometimes you just want to get through the lesson, but trust me, I'm doing them for your benefit. If I ask you to add, and I may have even shown you something like this already this year, 3 over 8 plus, it doesn't matter. I'm going to change it to 3 over 7. No, I'm going to change it to 3 over 5 plus 11 over 5. Okay? So if I ask you to add those two fractions, you were taught some abstract rules at some point. I know you're taught about fractions using pieces of things, and it's confusing. But you are taught that what you do is you put this all over 5, and you go 3 plus 11, which means you get 14 over 5. And I'm going to give you some advice here that I think is valuable. Do not think of this question as 3 over 5 plus 11 over 5. Think of it as 3/5 plus 11/5. It's no different in principle mathematically than having 3 puppies plus 11 puppies. You're going to get 14 puppies. And this is why we have the concept of a common denominator, because this means 3/5, and this means 11/5. It's no different, everybody, than 3 root 2 plus 11 root 2, right? It's 14 root 2s. So this is why we need a common denominator. So going back to our work here, the common denominator would be 5. You need to multiply the top and the bottom of this by 5, which means it will be -4/5 plus, I don't know why I put a negative there. I'm multiplying the top and the bottom of this by 5. And then we have plus -25/5, so we end up with -4 minus 25 all over 5, which, unless I'm mistaken, is -29 over 5. And I know that you would much rather, because it's easy, and this isn't an insult, it's just a statement of fact, take -4 divided by 5 plus -5 and go math, enter, enter, then do the work. But again, in the next unit, you're not going to be able to do that because they're going to be algebraic expressions, algebraic fractions. This becomes -3 times 29 over 5. So -3 over 1 times 29 over 5 is -57 over 5. Am I right? 3 times 29 is -57? No. -87. So it's -87/5. Be very careful here, because you might look at this question on an exam and go, well, it's absolute value. It's got to be a positive number. This isn't positive, and it's correct because it's -3 times something. E, they just get progressively, or 4, they get progressively more difficult. I would like everybody to figure out what the inside of this simplifies to, please. So I would like you to figure out what -4 in brackets cubed minus 4 cubed is. Well, -4 in brackets cubed means -4 times -4 times -4. If you're going to put this into your calculator, you need brackets around that negative. And then minus 4 cubed, we don't have brackets around that negative. It's just minus 4 times 4 times 4. Anyway, I get -128. So this is the absolute value of -128, which is just 128. B, oh, smokes. Well, let's deal with the absolute values first. I have 4 times -6 times the absolute value of 3/4, which is just 3/4. Thank you. -6. Then I have minus 2 times the absolute value of -1/4, which is just 1/4. So all I've done in this step is I've just rewritten it, but because it was the absolute value of a negative for the 1/4, I got rid of the negative when I dropped the absolute value signs. It's just a matter of cleaning this up now. And by the way, this up here is just 4 times -6 times 3/4, right? We don't need brackets embedded within brackets. And this 4 on the bottom cancels with this 4 on the bottom of the bottom, leaving you with, well, I guess this isn't the bottom. This is just the expression. This 4 cancels with the 4 underneath the 3 to give -6 plus 3, which is -18. And then we have -1/2 because 2 times 1/4 is 1/2. -18 over 1 minus 1 over 2. I have to multiply the top and the bottom of this by 2 to get -36 over 2 minus 1 over 2. So my answer is -37 over 2. And by the way, as much as I say you need to know how to do this on paper, there's nothing wrong with just using your calculator. Speaking of using the calculator, why don't we just take a break and use our calculator? Let's calculate with the calculator what's inside of here. What's inside of the absolute value signs? Which means I have to take 5 times 2/3 and subtract 8 times 5/6. I mean, there comes a time in everybody's life where you want to use the luxuries that are afforded to us. Why don't we use a calculator from time to time? It's that. So that as a fraction is 10 over 3. So we get the absolute value of -10/3. Are we all in agreement there? Okay, so then it's 10/3. We want to be really fancy. I want to see where we're at here. Let's do this one, and then I'll show you how we can really use our calculator to our advantage. We have to take -7 times the absolute value of 25 minus 64 all squared. So I've squared the 5 to get 25. I've squared the 8 to get 64. Now I'm going to take -7 times the absolute value of, I want to say -39. 25 minus 64 is 39, quantity squared. This becomes -7 times 39 quantity squared, which becomes -273. The -7 times the 39, quantity squared, who can tell me what I've just done wrong?
You didn't put the quantity in brackets, which means 2 times -273 by 273.
Right. All this means is I took -273 times 273. It's like taking -1 times 273 squared. You need to put the negative with the 273 in brackets and then square it. I don't know if you noticed, but I was just, instead of going to do that, I was just going to do this. Whoops. Because I know that when I square a negative, it becomes positive, so I wasn't going to waste the time putting the negative there. By the way, we get 74529. 74529. Is this positive because there's an absolute value in the question? No, it's positive because we're squaring something. All right, we have one last question to go, but let's go back to D and I will show you something. I guess if I wanted to know what all of this is, I could enter the following. Bracket, -7, and then I'm going to say absolute value. There's an absolute value function here. It's in the math menu. So you go to your math, which is under the alpha key. You scroll over to the, it's too bad that it's buried inside of all of this. You scroll over to the number menu, and there's ABS. And when I hit that, this is what I see. And this means -7 times the absolute value of what's to follow. Can you help me out here? So Logan, right? Do you, when you do it on your calculator, do you see a line? Do you see the vertical lines? You do. So on some of your calculators, you're going to see the vertical lines, which is even nicer. I don't know if my 84 emulator will do that, but I'm about to find out. Bracket, -7, math, absolute value. Yeah, it does, which is a nice feature. Okay. Does anybody have a TI-84 or higher that doesn't do that? Okay. And then I can enter, if I'm working on this calculator, I can enter 5 squared minus 8 squared. So this is the height of laziness right now. Scroll out of here. Close your brackets on the whole thing and go squared. You get that number. Over here you would go 5 squared minus 8 squared. Close the brackets on everything and square it. You get the same number. I'm just curious, totally not related to the topic here. How many of you sometimes are typing stuff away, maybe on this calculator, and you go -7, I'll put the brackets, -7, and then absolute value, 5 squared minus 8 squared. And then you keep typing, but sometimes your calculator, I can't get in there, there we go. Sometimes your calculator ends up typing stuff up here and you're not paying attention. You know what I'm talking about? Okay. If you don't like that, you can change your calculator setting. So, and what's going to happen is it will look like this now. But it also, there's an advantage here. I'm not trying to talk you into one mode or the other, but I want to show you this. How many of you sometimes have a long thing that you type, but as you type on this calculator, it goes off the screen, right? And you can't see what you've typed. So if I continue typing here, I'm losing what I've typed, and there's no way for me to see the whole thing. If I continue typing here, whoops, can't do that. It wraps around. And I like that, especially if we're entering functions, because if you have a long function in 30-1 and it goes off the screen, you can't see if you made a mistake or not. So anyway, if you go to mode on this calculator and you scroll way down, there's something called math print, which is the mode you're in, or classic. And if you go classic, now when you square something, it doesn't force you up there. When I type, 85 raised to, I'm going to see that. It won't bump me up there. As well, it will wrap around. I know I've gotten off topic here, but just to let you know, some of you might benefit from that. All right, let's take a look at one last thing. Now, how many of you have taken Chemistry 20 or are in Chemistry 20 right now? Okay, so you've probably seen something like this before, I would imagine. Okay, which is percent error. And percentage error is found by taking an experimental result of an experiment, subtracting what you should get, then dividing by the theoretical value then taking the absolute value of it and multiplying by 100. So you recognize this? You taught this in chem? Okay. So I'm going to give you a physics example here. The acceleration due to gravity here in Alberta is about 9.81 or 9.8 meters per second squared. This is the rate of acceleration of falling objects. Peter and Sue do an experiment, and Sue measures the acceleration due to gravity to be 10.4, and Peter measures it to be 9.3. What's the percent error for each one? So the formula that you're looking at says you take the experimental value, which for Sue is 10.4, minus the theoretical, 9.8, over 9.8. You take the absolute value of that and you multiply by 100. Peter is going to have the absolute value of 9.3 minus 9.8 all over 9.8 multiplied by 100. And I would like everybody to calculate both of those. So you have to simplify or calculate what's inside the absolute value first. Once you've done that, then take the absolute value, then multiply by 100. You have to hit enter after the minusing unless you're willing to put brackets around the entire numerator. Okay, so for Sue's, when I calculate what's inside the absolute value signs, it's positive, so I don't need the absolute value signs. I just can multiply this by 100. So Sue is about 6.1% off. And let's take a look now at Peter's. And I know that you probably have this already, but bear with me. I'm going to take 9.3 minus 9.8, hit equals. I'm going to divide by 9.8. And I get this number in the absolute value sign. So listen very carefully. Think. I know it's late in the day and sometimes our brains get a little tired, but what do I have to do to make that into the absolute value of that number? I suppose I could erase the negative somehow, but mathematically, what do I do to this number to make it positive? Times it by -1. This is what I was talking about earlier when I said the absolute value of x is negative x if x is negative. Here's the absolute value of this number. It's going to be negative of that number to get the absolute value. Then I multiply by 100 and I get 5.1%. Now I have one last thing to discuss with you, and then I will let you get started on your assignment. And I'm only discussing this with you because I am a physics teacher, and the science of physics is more precise than the science of chemistry. There, I said it. See, in physics, we say we don't use the absolute value signs in physics. We don't. Because the absolute value signs remove important information from the experimental results. I'm just talking about physics here, not math. This would still be 6.1, wouldn't it? But this would be negative 5.1. This is positive 6.1, that's negative 5.1. What do you suppose we care about in this regard for getting a positive versus a negative? What is that telling us? Right. Sue is 6.1% too high of a value or a result. Peter's 5% too low. That positive or negative can be useful, but, in math and chemistry, because they're not as precise, and we need a way to teach you absolute value, we use that. By the way, in chemistry, maybe to be fair, in chemistry, it's not as important whether you're above or below the results. It's just important how close you are. But in physics, we tend to say it's important. So I'm going to give you some time to get started on this while I get your assignment ready to hand out to you. which you'll probably get in about 15 minutes. At that point, once it's handed out, I will briefly explain the expectations for the assignment, and then the remaining 10, 15 minutes can be spent working on this stuff or the assignment. Right? So get to work, please, and I will be with you shortly.